So today's session we are going to talk about datasheet terms. Among the factors that a designer must consider when specifying which type of components should be used in a circuit design are value tolerance, temperature, stability, power rating, voltage rating, speed, humidity, aging, reliability, and not forgetting cost and availability. Now we discuss on each element, starting with tolerance. So when we say tolerance, we are talking about a factor that indicates by how much its actual value might differ from its stated value under normal use. For example, if we talk about a resistor having a tolerance of plus minus 10%, could have a worst situation, a value which is actually 10% higher, or a value 10% lower than the stated value. In other words, a resistor which has a stated value of 1,000 ohms and a tolerance of plus minus 10% could have an actual value as low as 900 ohms or higher as high as 1,100 ohms. The next term we talk about is what we call temperature coefficient. And where a manufacturer quotes the temperature coefficient of a component, these parameters state the typical amount by which a component's nominal value will change in response to a change in its temperature. And at times, temperature coefficient is abbreviated as TEMPCO. Another datasheet term that we ought to discuss is voltage ratings. All components are specified to work correctly up to a stated maximum voltage. It is likely that working voltage may also be quoted. The working voltage is that which the manufacturer recommends for the component's normal use. The next term that we ought to know and discuss is the amperage rating. And where quoted, though it's not quoted for some components, it is the amount of current which can be safely passed through a component and is usually stated in amps or milliamps. A related component datasheet term is power rating. A component's power rating is expressed in watts or fractions of watts, e.g. milliwatts, and it refers to the amount of power, and power is voltage times current, so it is the amount of power which that component can safely handle without becoming overheated. Speed. Of course, speed at times you'll find that it is similar to frequency, but they are different datasheet terms. So speed may be quoted in regard to how quickly an IC, for example, responds to a single event. And frequency response, though it is in the same context, frequency response is the rate at which the component can handle and process repeated changes on all inputs and through subsequent internal operations. We can also quote frequency in the context of the same with regard to capacitors, transistors, and coils. And here, the frequency value is usually the maximum that the component will respond or allow to pass through without degradation of the signal's amplitude or the waveform. Another datasheet term to be considered is reliability. Out of a batch of so many identical components, the reliability parameter states the quantity which might perhaps fail over a period of time, and usually it is a parameter which is available from manufacturers directly or sometimes through data books. It is normally of concern only to those who are buying many hundreds or thousands of the same devices. It is essentially meaningless to those who are merely buying few from a retailer. Other terms that you can take your time and read to understand includes humidity, stability, aging, leakage current, and so many others. Thank you.